we're going to look specifically at triangle. We're going to look specifically at triangles, but just understanding the basics of similarity. Now, you guys have also spoken about in grade 9 this concept of congruency, which we'll chat about now, just to recap and remind. That if two shapes are similar, what that means is that, oh, very aggressive, is that they have the same shape, but different sizes. Okay, so if you think of, say, for example, something like, I don't know, a square. This thing's going to allow me to draw a square. Oh. So there's my square. And let's say, for example, all of its side lengths were 2. A shape or square that is then similar to this one would be one that is exactly the same shape, so still a square, but is proportionately a different size. Let's say all of these sides were 6. What this shows us is that the square on the right is 3 times bigger than the square on the left. That is in proportion. When we say different sizes, really importantly, they are still in proportion with each other. So I can't just have one side length being doubled, the other tripled, the other half. They all have to be following the same sort of logic, the same proportion application to their actual length. So that's what it means when shapes are similar. Excuse me. When we now get to triangles, because as you've seen hopefully from Monday's lesson, the focus when it gets to grade 12 geometry is triangles. We are going to look specifically at similar triangles. Now, the same applies. They're still the same shape at different sizes. And what we need to remember is that we know how to prove shapes and specifically triangles are similar. So if you want to prove that 2 triangles or more are similar to each other, there are 2 ways to do it. The first way that you can do it is by showing that all corresponding angles are the same. The second way that you can do it is to show that your sides are in proportion. Now, the angle, or showing that your 3 corresponding angles are the same is the one that is used most often. So for example, what I mean by that is, let's say you had these 2 triangles here. Okay, we're just going to pretend that my triangles are fine. And if you could show that all 3 corresponding angles are equal to each other, then you have shown that those shapes are similar. They're very clearly different sizes. One is much bigger than the other, but they are similar because the corresponding angles match up. So like I say, angle is the one we use most often. Just because generally speaking, you would have found angles somewhere else using other geometric theorems, and then you're going to show that they're similar to prove that they're in proportion and then answer a bunch of questions. So that's how we prove similarity. Now, what I just want to remind you of quickly, and it's not super important for this specific section, but it is important just in general because you use this in some of your proofs, is congruency. Can anyone tell me what congruency is? Anyone? What does it mean if shapes are congruent? No one, guys? Okay, congruency and similarity go hand in hand. Congruency means that the shapes are identical. So similarity, same shape with different sizes. Congruency means that the shapes are identical. So same shape, same size, everything about them is exactly the same. All right, so when it comes to congruency, there's 4 ways to prove congruency. You can have side, side, side. Let's do that. Side, angle, side, side, angle, angle, or right angle, hypotenuse, side. So those are the 4 ways that you can prove congruency. Now, congruency is particularly important when it comes to some of your circle geometry proofs. Okay, some of those proofs do rely on you being able to prove that triangles are congruent, so it is really important that you remember that. But obviously, we're going to focus on similarity. I'm just reminding you of what congruency is. Okay, so I'm going to just wait here for like a second or two in case you want to take a screenshot, but let's have a look at our first example where we now actually go and prove similarity, use the similarity, do all of those fun things. Apologies, I'll go through what these things stand for now. So SSS means showing that all 3 sides are equal to each other. SAS is side included angle side. So when I say side included angle in a triangle, that's not a triangle. In a triangle, you would have to show that corresponding sides are equal to each other. Sorry, this is a really poor attempt on my part. And then you'd have to show that the angle in between them is equal. Side angle angle is exactly what it says, but RHS is a special form of side angle side where we show that you have a right angle, a hypotenuse, and another side that all correspond with each other. So RHS is a special form of side angle side where it's right angle, hypotenuse, side. Okay. Let's have a look at our first example here. So guys, remember when you are doing geometry, it's really important that you read all of your information. Okay, that seems like a really silly statement. I do understand that. But we need to actually know what we're working with before we can answer any questions. So here we've been told we've got triangle PST. In that triangle, TS is perpendicular to PS, and RQ is perpendicular to PT. And then we want to prove a bunch of different things. Okay, so we can see all of that information given to us on the diagram because we can see obviously the right angles that have been given to us. So the TS perpendicular to PS over here, and the RQ perpendicular to PT over there. So we've got those right angles. Now the 3 questions we've been asked are prove that they're similar, and just remember these 3 vertical lines mean similar. So just as a little tangent. So if something is similar, the symbol that we use is 3 vertical lines. If something is congruent, the symbol we use is 3 horizontal lines. So that's asking me to prove the triangle similar. And then I've been asked for some ratios and some products. We'll get to those 2 in a second. Let's first focus on the similarity. So I'm wanting to prove similar. Cool. I know that there's only 2 ways for me to do that, either angle, 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 or to show that all my sides are in proportion. Now guys, the problem is I've got no information about the sides here. I have got no cooking clue what the lengths are, what the ratios are to each other. I can't use sides in proportion. That's just not going to be possible here. What that means is that I'm going to have to use angle, angle, angle. And that's what I said to you earlier. Angle, angle, angle is the more common method of proving similarity. All right, so when we do prove similarity, the first thing that we do is we state the triangles we're working in. So in triangle PRQ and triangle PST. Now, personally, I like to highlight my triangles because sometimes these diagrams do get quite complex. And honestly, to see what you're working with is sometimes a little tricky. So I just like to highlight it so that my brain can comprehend what it is I'm doing. So there's PRQ. Cool. Okay, there we go, PRQ. And then we've got PST, which is the big triangle that I was initially given. So P, ST. Now I want to prove that they're similar. Now remember, we've just established in this case, we can only do that proving angles are the same. So now we have to look in those two triangles I've highlighted and see which angles are the same size. So have a look. Can anyone give me two angles in the two different triangles that are the same size? Look in your blue triangle, look in your yellow. Does the blue and the yellow have the same sized angle? Perfect. Okay, Bonga and Corsia said R1 is equal to angle PST, which is the 90 degrees, which exactly. Remember, we were told RQ is perpendicular to PT, so we know R1 is equal to 90. And we were told that TS is perpendicular to PS, so we know angle S or PST is equal to 90. Now, there's a couple different ways that you can say this. R1 is equal to S, which are both equal to 90. You could then give your reason as given. Or you could leave out the equals 90, and in your reason, you could say both equal 90. It's up to you. That's how I say it. Up to you. Alrighty. So that's my first angle. Second angle that's equal. Any suggestions? Nice. Camila. Simla. Jeez Louise, my words there. Okay, exactly. Angle P is common. So guys, if you have a look at your blue and your yellow triangles, hopefully what you see is that they overlap at the angle P, which means that P, that angle, exists in both triangles. And so angle P is common. Again, there's a couple different ways you can write that. I just say P is a shared angle, or you can say a common angle. Another way some people like to write it is angle P equals angle P and then reason shared angle. That's completely up to you. Whatever. I say P is a shared angle. That's how I do it. Okay, so this is the same. Now, guys, what you need to remember is that if two of your three angles are the same, that automatically means that the third angle has to be equal. So if you already know two of the three, the third one has to then be the same angle. So that means that angle Q2 is equal to angle T. And the reason for that, remember, is sum of angles in triangle. If you already know that all three of them must add up to 180, and if you already know two of the three, the third one then has to be the same in both of them. It's not possible for it to be anything else. So what we've now done is we've got our three angles. And so what we can now say is that triangle PRQ is similar to triangle. Now, we have to get the order correct, because if we don't get the order correct, answering the next two questions is going to be like finding a needle in the haystack. Now, when I say we have to get the order correct, we have to make sure that the corresponding angles match up. So angle P was the same in both, so we can start with angle P. Angle R corresponded with angle S, so PS, and angle Q corresponded with angle T, so PS, T. It's really, really, really important that that order is correct, because if it's not, you trying to find ratios and stuff is going to be impossible. So we have to get the order right. Generally speaking, grade 12s, they do actually give you the order correct in the question, but it's always good to check just in case. Okay, so we've answered the first question. We now know that these triangles are similar. And because we know that these triangles are similar, I need to have my reason, angle, angle, angle. Because I know that these triangles are similar, I now know that their sizes are in proportion. So for example, if one side length was doubled, all the other side lengths are in proportion and so are doubled. So that proof of similarity now gives me that they're in proportion. Now this is going to help me when answering question B. So question B is asking us for the ratio of RQ to PQ is equal to FT to PT. Now those ratios, remember, essentially we've already proven that everything's in proportion. So we've already proven that the ratio to sides is equal. But we need to make a mathematical statement to that effect. The way we do that is as follows. And I'm just going to take my green and my yellow highlights here. So it'll be a bit easier to see. So we do this as follows. We take the proof of similarity that we have just done, and we line up the corresponding sides. What I mean by that is your first two letters PR corresponds obviously to the side PR. That is then in proportion to the first two letters on the other side, PS. So those two sides are in proportion with each other. Then we move on to the next. We take the next two letters, that would be RQ, so the green side here, and that is in proportion to ST, again the green side over here. The last side, obviously you can see it on your diagram, but the last side is the first and the last letters, that's PQ. So in my small triangle PQ corresponds in my big triangle to PT, that whole length over there. So what we have done through similarity is we're showing which sides are in proportion with each other and which sides have that relationship. And so to now answer question B, we can set up this relationship, because remember question B is a ratio. It's not asking for the proportions of sides. We now have that. So we now know that PR, so what I showed you in yellow, PR is in proportion to PS. We also know that RQ is in proportion to ST, and we know that PQ is in proportion to PT. And because of similarity, we know that all of those proportions are equal to each other. That's what similarity has allowed us to prove. Okay, so now we can go and have a look at what it is we actually want. So if you go back to your original question, we're looking for RQ to PQ is equal to FT to PT. I go to my ratios that I have here and I go and see which ones contain those letters. So there's RQ, there's PQ, there's FT, there's PT. So in this case, I'm actually only wanting to work with the last two ratios here. Those are the only ones that concern me for this particular question. So I am working with RQ over ST is equal to PQ over PT. Now have a look at what the ratio is actually saying to us in the original question. The ratio is asking us to compare RQ and PQ. RQ and PQ are my two numerators. Cool, I can compare those. It's also asking me to compare ST and PT. ST and PT are my two denominators. I can compare that. And so once you set up this fraction, the ratio is saying numerator to numerator is equal to, and we know it's true because of the fact that they're similar, is equal to denominator to denominator. And so just by setting up those fractions, we have been able to prove that those ratios are equal. And again, they're equal because we know that our triangles are similar. All right, so guys, I know it's not like the easiest concept to understand, but what you need to remember is that similarity goes hand in hand with sides being in proportion. This is why similarity and proportion are tested together. They go hand in hand. So once you've proven similarity, you automatically know that proportion applies. All right, question C is asking us to show that PR times PT is equal to PQ times PS. We do exactly the same thing. We look at our ratios. Now, obviously, you don't need to rewrite the ratios. I'm going to, just so that we can have a look. So PR over PS is equal to RQ over ST is equal to PQ over PT. And again, we do exactly the same logic. Look at what we want. We want PR and PT equal PQ, PS. Here's PR, here's PT, there's PQ, there's PS. So in this case, I'm actually working with the first and the third fraction. So I take those, PR over PS. Okay, it's going to fight with me, so that's cool. PR over PS is equal to PQ over PT. Now look at what you want. We want, we'll go back to this original question, we want PR and PT together. So that means PT needs to go join PR, and then we want PQ and PS together. So PS needs to go join PQ. Now, if you look at what I've just drawn, that's just cross multiplication. This also makes sense because remember that dot in the middle is a multiplication. PR times PT is equal to PQ times PS. That's exactly what I wanted to prove. I'm done. Okay, so when it comes to these types of questions with the ratios and with the products, really, really important, your very first step all the time needs to be the step of setting up your corresponding sides that are equal to each other. That has to be your first step. Right? Once you've got that, you can then go and see which fractions are you working with, which fractions are going to help you prove what it is you're wanting to prove. Alrighty, now again, you can only set up those fractions if you have correctly put the order of your triangles. If the order of your triangles and similarity is wrong, then unfortunately the fractions that you're going to write down is nonsense. So we need to be very mindful of that. Okay, so I'm just going to wait for a screenshot, and Camilo, I see your hand. So ask away.
Ma'am, I have a question about the one where we were showing that PR is in proportion with PS. Like, how do we figure that out for the triangle?
PR is in proportion. Okay, so this is what I was saying, that the order is so important. Once, sorry, my cat has decided to join us. Once we have proven similarity, we will write down the statement that the triangles are similar. Great, wonderful. But the order in which you write it down is so important. Now, I find it easier to match up the angles. It's easier than trying to match up sides. So angle P matches up with angle P. So that's why we started with P in both of them. Angle R matches up with angle S. So that's why my next letter here was S. And angle Q matched up with angle T. So that's why T was my third letter there. Once your order is correct, your sides match up. So in this first triangle, we've got a side PR. Side PR. We've also got a side RQ. Side RQ. We also then have the last side, which is PQ, which if you have a look is your first and your last letter. Now, because of where the angles sit, and because of the fact that those angles correspond with each other, the order we've now written the second triangle automatically corresponds as well. So because we've made sure all the angles correspond, all the sides correspond correctly as well. So what that means is if we go to the side PR, so let's just take all of these scribbles off. So here's side PR. Because of my order, that automatically corresponds to the first two letters PS. So that's the side length over here. And basically what it means is if you were to take these triangles and sort of turn them, twist them, do what you need to do to match up the angles, those sides would then all match up with each other. So if we were to take triangle PRQ and we were to put it on top of angle PST, PR and PS would line up with each other. RQ and TS would line up with each other. And then PQ and PT would line up with each other. They are the ones that correspond and are in proportion with each other. So that's why getting the order of your triangles is so important, so that you don't have to try and imagine triangles on top of each other and what lines up. If your order is correct, and like I say, generally they give it to you correctly, you're sorted. So Camilo, I don't know if that answers your question. I don't know if that helps.
Yes, ma'am, it does. Thank you.
Perfect. Perfect. Okay, I also have a question here. Would I lose marks if I don't show my working in B? So you don't have to show a lot of working. So, I mean, my working that I have here is minimal. What you do need to show is that you know that the ratios are all equal. So if that's the only, sorry guys, if that's the only thing you show, that's okay. But what we're essentially testing here is the fact that you know that all of those corresponding sides are in proportion. So you have to show me that you understand that, and then you can get to your answer. Because obviously once you've got that, getting to your answer is pretty much one step. But please do show that one with a little star there. My throat. Okay. So I hope that clears up that question as well. If not, obviously just let me know. Right, guys, I'm just going to wait 2 seconds in case you haven't taken your screenshot. And then I'm going to put one up that you're going to try. It's pretty much the same question, just with a different image. Right, so you're doing the same thing, same method. Follow the steps that we followed here, and you should be good. Okay, so here it is. Apparently I didn't do answers, but I do have answers. I'll put them up in a second. Let's try this. No, we're doing this. I know it says example 2, but try. And then we will have a look. Okay, you will need a few minutes. I'll give you like 5-6 minutes, and then we'll check in and see. guys, I'm going to give you 1 more minute and then we'll have a look. Okay, let's see. Right, so there are your answers. So in the first one, next class is now with it. So for the first one, you're proving similarity. Okay, and remember, because you've got no information about any of the sides, you can't try and show that sides are in proportion to prove it. You don't have enough information. So that means you're going to have to use angle, angle, angle. And so we know, or we were already told that B1 is equal to C because of the parallel lines. Remember, I told you PA is parallel to BC. You've got alternate angles in A1 and B2. And then because of angles in a triangle, you know that angle A2 and P are the same. Okay. Make sure you match up your angles. So remember, if I'm going to use the order PAB, try that again, PAB, my angles must match up. The angle that matches up with P is A. The angle that matches up with A is B, and the angle that matches up with B is C. So once that order is correct, you can then set up your ratios in the next question. So in question B, sorry about the green scribbles, but it's okay. In question B, you set up your ratios. Now, guys, remember what you're doing is, do you match up the first two letters with the first two letters? So that's why PA over AB. Then you match up the next two, so AB and BC, so that's why AB over BC. And then finally, you match up first and last, so that's why PB over AC. Then you just manipulate to get what you want. So what we see here, PA over AB, you're comparing numerator denominator with numerator denominator. That's what you have. You can now just write the ratio. When it comes to C, again, you double check which one you want to work with in terms of which fractions you want to work with. And once you know that, you set it up. Generally, if it's a product, you're going to have to cross multiply and you get the product that you want. All right, so take screenshots. If you've got questions, obviously, please ask, and please make sure you continue to ask questions as we go along. Let's now have a look at another one where we start to use this idea of similarity and the fact that it then means our triangles are in proportion to work out unknown lengths. Okay. Okay, I know it says you try, but this is the example. I don't know what happens to my notes because it's not what I have. But anyways, it's fine. Okay. Example 2. We want to calculate the lengths of, and I'm actually going to stop this. It's going to make it a lot easier. DE and AE, but we've been given some information. So let's again always read your information. Make sure you know what's going on before you just dive into a question. So we've got the diagram below. The diagram below shows triangle ABC. And it says that DE is parallel to BC. So DE parallel to BC. Now, guys, what I want you to remember is we've learned about the proportion theorem. So proportion theorem states that when a line is drawn parallel to one side of a triangle, it cuts the other two sides proportionally. We have that here. We've got one line drawn parallel to one side of my triangle, and so it'll cut the sides in proportion. Now, for sake of the fact that this lesson is not on proportion, it is on similarity, I'm not going to use the proportion theorem, but please understand that in a test, you definitely can, right? There's nothing wrong with that. But obviously, we're trying to practice some similarity here, so I'm going to use similarity. So questions asking me to find the length of DE, which is this length in the middle, and then the length of AE, which is this line segment over here on AC. All right, so yes, you definitely can use prop theorem, and prop theorem will definitely help you to get AE. But remember, we spoke about the fact that this third side has nothing to do with the proportion. So it'd be very hard then to find DE using prop theorem because I've got no information about it. What is useful is me finding or me determining whether or not these triangles are similar. Because remember, if the triangles are similar, all sides are included. All three sides of my triangle we can then say are in proportion. So that's really helpful, especially when it comes to finding the length of DE. Okay, so that's the first thing I'm going to do. I want to prove similarity. So we set our triangles. So in triangle, now obviously I'm working in the big triangle ABC. But the second triangle that I have, and I can figure out which that's going to be because I want AE, is triangle ADE. It's a weird looking ad. Let's try that again. Doesn't get any better. It's fine. Alrighty. So now that we have that, we are going to prove similarity. Now, guys, yes, I do have information about some of the sides in my triangle, but I don't have enough information. I would need all three, or all sides rather, to prove that they are in proportion. I don't have enough information for that. So for this, I am going to have to, excuse me, prove angle, angle, angle again. Right, I'm just going to stop quickly because there was a question. The question is, when are we going to do a question where the order is not given to us and prove that the triangles are similar? This is the exact question. The order isn't given to us here. I've just made up that order, triangle ABC and ADE. It's fine to make it up at the start. It's when you make your final statement that it has to be correct. So this is the exact question that we're doing right now. Okay, so guys, first things first, we can see that angle A is common to both of those triangles. So angle A is a shared angle, a common angle, or angle A equals angle A, whatever you want to say. So that's my first one. The second thing I can now do is, because I have those parallel lines, I know that I've got some corresponding angles. Now, it doesn't matter which ones you say are which. You can do whichever one first. So I'm going to start with angle ADE, so the ones with the stars. So ADE is equal to angle B, or you can say ABC, it's up to you, but there's only one angle at B, so I can just say B. My reason, corresponding angles. And remember, anytime you use a parallel line reason, you have to state the parallel lines that you're working with. So parallel line reasons, corresponding point area ultimate. This is DE parallel to BC. And then your third reason, you have a choice. You know that they're corresponding, but you could also use some of the angles in a triangle because we've already discussed the fact that if you've got two of the three, the third has to be the same. So it's completely up to you. I always just use some of the angles in a triangle for my last reason. So I'm going to do that. But if you also said corresponding angles, that's fine. Okay, so now we've proven that all three angles correspond with each other. And so what we've proven is that triangle ABC is similar to. Now, this is where we have to double check our order, because remember, this was not given to us. I made that up to just label the triangles I'm working with. So I need to make sure that I correctly match up the labels. So we start with angle A. Remember, angle A was shared. So in this triangle, it's going to be A as well. Then we move on to angle B. Angle B matched up with angle D. So that's step number 2, so AD. And then angle C matches up with angle E, so ADE. So that's how I check that I've got it right. And like I say sometimes we don't give you the triangles initially, and you sort of have to know that similarity is necessary in order to get what you want. And so we do then need to be extra careful of our order, but we have proven similarity. It's in the correct order, so we're sorted. I don't know why I'm underlining that because that's not my answer. So now that we've got similarity, what we have now proven is that these triangles are proportional in size. And so I'm now going to use that to work out my unknown lengths. So to do that, remember we set up our ratios. So the ratios are obviously those side lengths that correspond with each other. So first two, AB over AD. AB corresponds with the next two. So BC over DE, which corresponds with the first and the last, AC and AE. Okay, so that's what I have. Now I go back to my question and I ask myself, well, what am I trying to find? Cool. The first one that I'm looking for is DE. So I look to my ratios, there's DE in that pink fraction. So cool, I'm definitely going to have to work with that fraction. The next thing that I check is of the side lengths that I was given, where do they fall in my fractions? Okay, so AD is 15. So there's AD. I've got that one. BD doesn't fall in any of these fractions, but if you have a look, the whole side length AB, I do actually know because it would be 15 plus 3, which is 18 units. So AB I know. I was given at the bottom BC is 21, so I know BC. And then EC, again, it's not in any of my fractions because it's just the segment of my line. I've been given it, but it's not going to feature here. So based on everything that I have, I'm going to work with these first two fractions because those first two fractions have all of the information that I need in order to solve for DE. So AB, hates me. AB over AD. Okay, no, it's not going to enjoy that either, so just go here. Equals BC over DE. Now guys, remember, ideally, if we can get our unknown in the numerator, that's winning. Now you can always swap your fractions. So to get DE in your numerator, you would now have DE over BC is equal to, and remember to flip the other fraction, AD over AB. It just makes it easier. These mean exactly the same thing. So there's nothing wrong with flipping the fraction. And like I said, it makes it so much easier to solve if your unknown's in the numerator. So now we fill in the information that we know. AB is 18. Technology. Yeah, so Charles here. AB is 18. AD is 15. I don't know why I'm choosing to do that. We're using this fraction. So DE over BC, which is 21, is equal to AD, which is 15, over 18, which is AB. Now this is easy. DE is equal to 15 over 18 times 21. Okay, it's the same as what we were doing in prop theorem. And now that we have that, we know that DE is equal to 17.5 units. All right, so all through similarity, I was able to find the length of my side. Okay, because of similarity, I know that the triangles are in proportion, and because of proportion, I can go and work that out. Sorry, I just want to move this down a bit, otherwise we're going to run out of space. Right, so all because of similarity and all because they are in proportion, we were able to find that length DE. Now I know what DE is, so I know that DE is 17.5 units. I don't know why I put that at AE. 17.5 units. There we go. That's just an extra bit of information that I now have. Second, we get information, we want to add stuff to our diagram because now we've got more that we can use. So the next one that we were asked to find is AE. So if we have a look here, we want AE. and AE is this length over here. Now be mindful of the fact that AE is part of that whole segment. So let's say AE represented or was represented by X. What that means is that the whole length AC would be X plus 4. And so when you now go and have a look at which of the fractions are useful to you, bear in mind you do know what AC is. You just know what it is in terms of X. Okay, so I'm going to give you 3 minutes. I want you to try and solve for AE for me. Use what I've given you. So use the fact that we're going to say AE is X. And remember that that then means that the whole length AC is X plus 4. Give it a try. Let's see what we come up with. We'll go through it now in a second. But let's see if we can get the length of AE. I'll give you a hint. You shouldn't get any decimals. It's a whole number. Okay, I'll give you 1 more minute to finish off and then I'll do it and we can see if we all agree. One person's got it right so far. Very nice. Okay, guys, let's have a look. Alrighty. So I gave you 2 hints. Hint number 1 is let it equal X, and hint number 2 is that you should get a whole number as your answer. Sure. Okay, so technically speaking, when we represent something with another variable, we should state that. Stupid thing. So AE is equal to X. And then we go back to our ratios. I'm not going to rewrite all of these ratios. Maybe I'm going to rewrite all of these ratios. AB over AE. Okay. We're looking for AE. So that's that one there. So I'm definitely going to have to use that fraction. And remember, we know what AC is in terms of X. So that's great. Now, guys, from the pink fraction, so on this middle fraction, we knew what BC was, but we had to work out DE. Because you have worked out what DE is, technically, that means that you have that value. But what you want to do is you want to try and avoid working with values that you calculated, because it might mean that you've got something wrong or you've made a silly mistake and then you're going to use the wrong value. Obviously, we see a mark, but just try and avoid it. And we know that we've got everything in this first fraction. So why go and use the middle fraction where we know for sure everything in the first fraction is correct? So that's what I'm going to do. AB over AD is equal to AC over AE. Now remember, we want AE. So if you want to swap the fraction, that's fine. It's completely up to you. I have said though, try and keep what you want in your numerator. So to follow my own advice, I'm going to swap it. Obviously, I didn't then swap the first fractions, so cool. So this first fraction must swap AD over AB. Now I fill in what I know. AD was 15, AB was 18, is equal to AE, which is X, over AC, which is X plus 4. And now we start to solve. Now remember, it's one fraction on each side, so you can just cross multiply to get rid of the fractions. So you've got 15 times X plus 4 is equal to 18 times X, which is just 18X. And then we solve. Distribute 15X plus 60 is equal to 18X. If you now go and collect your like terms, 60 is equal to 18X minus 15X, which is 3X. And so dividing both sides by 3, X is equal to 20 units. Okay, so a slightly more complex solution just because of the algebra behind it. But remember, the algebra shouldn't scare you. Algebra you've been doing, and this, even like this level of algebra, you've been doing since like grade 7, grade 8. You can do it. It's just a case of making sure that you're setting up your ratios correctly, your values correctly to do so. All right, so I'm just going to make this a tad smaller so you can actually get everything. So you can screenshot that